All right, so let's start our class. So yesterday you've seen, about images and containers. So the commands, what used to, what commands we use to create them. How to run a container, how to go inside a container, delete it, you stop it, all these things. So even for images also. So and how to access your application from a container. We'll try that again today, no worries. But before going on today's class, any doubts so far? Any doubts in the comments?
Yeah, so when I Google about detached command, I saw a command called sleep.
Okay.
Uh, yeah, so the main use of that sleep command is for it will run for some time delay, right?
Yeah.
Suppose if I execute
It'll wait for some time. Yeah. Sleep for some time.
okay,
Okay.
will whether we will use in our work or
It depends. If required, we'll use it. If not, we don't. Why it is
okay.
required? Any scenario?
No, I don't have actually. I just asked whether we will use this sleep command.
Sleep is not a Docker command. It's a Linux command.
Okay.
So it will just sleep for few, whatever the time we mentioned. Let's say we give sleep 5, it will wait for 5 seconds. It'll do nothing, just sleep. Just giving a break. That's it, really. It's not a Docker command. It's a Linux command. So if requirement comes, yeah, we'll use sleep. If not, no. So that's what about it. So let's yeah, sorry, any other doubts? All right. Then let's start out today's class. We'll create few more containers in just before going to our main topic. Let's say I want to run Sonar Cube. Simply go here. Docker Hub. Docker Hub is a separate topic. I'll let you know. But before going that, let's know about how to create the containers and everything. So Docker Hub, Sonar Cube. Search for Sonar Cube. Anything. It does not matter. I'm just searching for Sonar Cube. That's it. Official images here. Tags. So maybe I can use the latest one. So it's fine. Now Docker run. I want to run Sonar Cube in background. -D. And I want to access the Sonar Cube, right? So I have to publish the ports. -P 9000. This is my host port. So I'm trying to use 9000. I'm trying to access the Sonar Cube which is running in the container by using 9000 port. Let's say if 9000 is not free, it's already being used by some other thing. You can use 9001. It does not effectively. So you have to use only one time the port. So you cannot repeat it. In the where in the host and right side is container port. Container port it should be correct. It should be the default port. No matter how, as I told you in the last class, no matter how many containers you create, the container port can be same because they are completely isolated. They won't have a conflict or anything. So now this is my host port and right side is container port. So I can access Sonar Cube by using 9000 port if everything goes well. So hyphen name, simply I'll use Sonar Cube. I don't have Sonar Cube image, obviously it will pull it. Right? Sorry, I gave the wrong name. Sonar container. Yes. So I didn't give any tag. See if you see here. Oh, wait. Let's. I gave the spelling mistake. Sorry. If I don't give any tag for the image, it will take the latest. I told you right. If you give any tag specifically, it will pull that. So you don't need to pull it manually. So run a container. If, while running, it will check for the image obviously in the local. If it is not present, it will download it obviously. So no need to pull again. So it depends on the size. It will take some time. Yes. Download that new image. Yes. This is the ID obviously. It means it's created. So let's check the status. Docker ps, it's running. Ps minus a, I think no other containers except this. So check the logs. How to check the logs? Docker logs minus here. What is the name of the container? Where is it? Sonar icon container. See, this is the log that usually we see in SonarQube. It's loading the plugin. Meanwhile, yeah, we can try. We can try loading this. This is my IP. This one of these loading. It will take some time, but yeah, obviously you talk. Now I want to run one more SonarQube. Let's take a scenario that okay, this is SonarQube. The version is still not loading yet. It will come. So maybe it's the latest version. I don't want to use latest. I want to use maybe a little older version. So at that time, I'll create one more container. Same Docker run hyphen d hyphen p. Now I have to give host port a different one because 9000 is already being used by another container. So host port should be unique. So maybe 9001 or 9090 anything. 9000. Right, container port has always to be the correct one, default one. So that's fine. Hyphen name sonar 2 and sonar cube. Sorry, tag maybe 9. 9 version I want. Let's try. 9 is there or not? No, sonar cube 9 is not there. Let's search. Let's search here. Yes, it came. I think default is admin. What? Ah, that's okay. Something. So you can set a password, but forget about that now. Let's try 9. I want 9 version. 9.9. Come, where is it? 9.9 enterprise, 9.9 developer, 9.9 something. But ours is community version, free version. So see 9.9. This is the image name. Let's run. No image. It will pull obviously. See Docker PS. See two sonar cubes are running in a different ports. Now let's open with 9090. Sorry. See, see that's easy to. That's how to create multiple containers. Think, imagine same scenario for application. I have application old version, new version. I can run parallelly. So there's no conflicts. But if you want to do the same thing in VMs, you need to have two VMs. So that's the difference. That's why the Docker, I mean the containers concept. Obviously, it will take some time. Don't worry. See, this is a little older version, and this is a new version. See, I can manage like this. We try anything. You can try anything, no matter what. You want to delete? Simple delete. You can just give a space and give a multiple. It will delete. Yeah, it's deleted. Try PS. Nothing. PS minus A. Nothing. We already deleted. Now, what I would say, let's try deploying our applications in container. We have already seen Tomcat. Let's try maybe sample WAR file we can deploy. So Tomcat, search for Tomcat. There it is. sample var file. This is the one we got. Download the sample var file first. Just download it. Let's see what is the tag for Tomcat. We tried this yesterday, but yeah, let's try again. I'll tell you why. What is the version? Maybe Tomcat 9. There will be lots of versions. All you have to find out which has more stars and use that. Or if it is size matters, obviously. So choose the one with less size and use it. Anything. There's no. Maybe let's take this and let it pull. So let's run docker run -d -p. What is the Tomcat port number? 8080. This is the host port I want to use. Right side Tomcat correct port number I have to give. What is the name? Simple Tomcat. What is the image? This one. This is the image, right? It's see it says address already in use. 8080 already being used by Jenkins. So I can't use the port. This is the error you see. So let's create 8081 maybe. Yeah, try. It's creating. Yeah, 8081 it's running. Let's access that. What will happen? Okay. Now I want to run my sample web app in here, right? Inside a container. What to do? Usually how we deploy in Tomcat, we simply deploy this artifact, whatever the jar or what, into web apps directory, right? Similarly here also in the container there is a web app directory. Obviously there will be. So but my var file is in local. So you can simply just copy it for now. Docker cp sample, what is the container name? Tomcat. We know this command already. Slash user slash Tomcat slash web apps. I hope this is the correct path. I don't remember exactly. No, there is no path. First, let's go inside a container. This exec-it Tomcat. Hope you know this command as well. We are executing shell, so shell will take us inside a container. So path is user local Tomcat web apps. Yeah, I gave user share. User local web apps. It's copied. Let's go inside a container again. cd web apps. Is our sample var file is there? See, let's access. See, this application is inside a container and it's working. See, that's how usually we deploy. I mean, in generally also in a Linux machine and without containers, we deploy the same way. Deploy the application into web apps. But here we doing the same thing inside a container. That's it. So that's what you're saying just now. Correct? Let's maybe download some other thing. Sample var file again. Let's down maybe this one. Okay, this gone. Maybe this one. Hopefully. Mm, see, they are using Tomcat 8. Some guy, some user named Saravak. He pushed his own image. But yeah, that's okay. Let's not sample web app directory and copy link address. You can download directly inside a container also if you have the wget command. Yeah, wget is there. Let's download directly. Or you can download in your local machine. Use Docker CP to copy the WAR file into web apps. Anything is fine. Sample web app is there. See, it's extra. It will accept by default. So you can copy it. Go here. This is our okay. Paste it. Blah 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 blah. See this one. That's it. That's how you deploy. Correct. So is it clear? We just ran a container and we went inside and we deployed our application manually. Let's say developer, he gave you the usually he'll give the artifact or he'll push the artifact into some artifact like JFrog or Nexus. We have discussed that. So usually you'll download from there and you'll deploy it. So okay, for the first time we deployed manually, all good. Second, developer push something and the new artifact generated. You have to deploy that one, right? Again, you did manually. Simply went into container. With wget you downloaded the what is it image or you copied the image, let's say from local, and you deployed it. Again, the same requirement comes because the changes will happen very frequent. So you can't simply just do like this. You can't simply just do like this manually. And one more thing, see this. We are using the Tomcat image here, correct? This is from Docker Hub, which we downloaded. It's a default one. Our configuration, which required for our application, our code, our artifacts, nothing will be there in that because it's the default one. We will be downloading that image and copying whatever required for our application and run it. Correct? Now we ran a container, so we copied our artifact into this container. Okay, all good, and we copied all our configuration. Let's say we have some other configuration, some property, something Java property, something all of there. We copied it. For some reason, container is deleted. Maybe like I in a hurry accidentally I deleted the container. Now what happened? All gone. I mean, of course, we have the image. Docker image is present here, obviously, but it's a default image which you downloaded. Your code, whatever you copied into a container. You copied into a container. The container is gone now. Again, you have to run a container. Again you have to sorry, copy all those things. Let's say that also deleted. It's repeating things. Instead of all these things, the scenario you're facing, I have to create a container manually. I have to copy my latest artifact every time. That is one thing. Once I copied, it's deleted. I have to recreate the whole thing. So here, what we are doing is, since we are using the default image from wherever, whatever the image is from Dockerfile, on top of the image, we have to do everything. We have to do everything, and then or whatever it depends on our requirement. I mean, whatever we want to do within this container, so we'll be creating a container with some image and we'll be deploying all those things. Instead of that, can I have my own image with all these configuration inside that, so that I can simply reuse the image, just create a container using that image. This is the default image, correct? I want my own image. So inside that image, I'll keep like sorry. So inside that image, I'll keep everything, my artifact, my configuration files, so that I can use that image, right? Even though if container is deleted, I can simply recreate the container with my own image. My own image have everything present. So you don't need to do all these steps, manual steps, correct? So I want to create my own image with all my requirements, with all my dependencies, with all my configurations and everything, my code and everything. so that I can able to use that. So that's when we build our own images. That's when we start using our own images. But how to do it? We'll do that. We'll see that. So let's say there are two ways to create an image. One easy way. We'll start with easy way. I mean both are easy, but yeah, we'll start with let's run a container. Let's run a container. Where is it? The command. Yes, this is the container. Yes, run it. And Docker cp. I'm just reusing the same command. That's it. Copy the sample var file web apps and sorry. Yep. So now there is a container running. Correct? There is a container running with my code, with my artifact, with my configuration. Everything. We can create our own image by committing this container. By committing this container, if you commit this container, you will get your own image. So if you want to you want to create your own image, you commit your container. How to do that? This simple command. Let's say docker commit container ID or name, whatever Tomcat. Let's say let's use the ID, uh, something whatever big one. Commit. What is the name you want to use? Anything. It can be like my own. So let's say Tomcat colon own. So what happens now is you have created your own image out of the container. So you created a container, some whatever it is, and you copied everything inside the container, and you committed the container. What happens? It will created an image for you with all the content whatever inside it. So let's see. Let's check the images. Do we have Tomcat own? See, it's your own image. Now you create container out of this. -d-p 8082 8080 name Tomcat own Tomcat colon own. Yes. It's created. So what will be the inside it? Whatever present the content present here in the old container will be present here. It means our sample file will be present. Let's check web apps. See, sample is there. Did I download it? No, right? Did I copy it? No, because I just created my own image out of the container which has this content, which has this data, and created a new content out of my own image. This is your own image now. You can you can use it. So like that. This is one approach of creating um, images. What happens here is, let's say now I created an image maybe 5 minutes ago. So now if someone make changes to this container, this is the container which out of this container only we created the image, right? If someone make changes in this within this container now, the changes won't be visible here because the image is already created. It's done. It's like a backup. You took your laptop backup, everything, your phone backup. Now after some time, once the backup is done, you added some new data to your laptop. Will that data be available in the backup? No, right? So it's like a timely backups, timely snapshots, where while at that point of doing your backup or a snapshot, the data will be present. Similarly here also, when you're committing a container, whatever the data present at that point of time will be present in that image. So you can create anything. Run a SonarCube container, commit that with your own some name. You have your own image now. That's how it is. Is it clear so far before going on? Is it clear? Any doubts?
No.
So let's let's imagine the scenario that this is working. All good. The container is there. We're committing the container. It has the latest file. But still, you're doing the manual work. Correct? Still, you're doing manual work. Why? You're just creating image out of the container. It means the container has to be up to date with your latest changes, whatever it is. It means you have to copy your latest changes to the container again manually. Uh, you know, in order to have the latest changes. What to do? Still, it's not a good approach. That's where this concept called Dockerfile comes. Dockerfile. So that's where it comes. Dockerfile. Dockerfile is it's a normal text file. Normal text file. This is this will be used to create your own Docker images. That's it. That's just to create your own images. We use Dockerfile. Just like we use a Docker commit command, right, to create our own container. Sorry, image out of the container. But with Dockerfile, we build the image from scratch. That's it. That's the only difference. Got it? So, one minute, just one minute. Yeah, sorry. So, with the Docker commit, it's fine. I mean, we can able to create our own image out of the containers, but still, we want to make sure the container is up to date. So, again, that's not a good approach. I mean, there is a lot of manual work involved. And we have to every time we have to make sure the container is up to date. So now let's say instead of committing this, instead of committing this, I mean, still people sometimes use commit sometimes, but not regularly. But instead of committing, we have a better approach called Dockerfile concept called Dockerfile, where we write a small, I don't say code or a script, a small, instructions, let's say, instructions, few arguments, or let's say, or few commands to create our own Dockerfile from scratch. Got it? So this Dockerfile is a text file, simple, just a text file actually, which we have to write the content in order to create our own image. So now what happens with this Docker file is once we write the file, we execute the file. It will build an image for you, and you can use that image. Let's say now your changes has been, your new latest changes are there, latest build is there. You have the Docker file, right? You simply execute that file. It'll, execute whatever the steps you gave inside the Docker file. Like let's say the steps you gave, like check out the code from there, build it something, or copy this artifact from there, something, copy the configuration file. So all these will re-execute again, so that you don't need to manually copy, download, or anything. When you execute a Docker file, whatever you kept inside that will be executed, and it will give you a new version of image. I mean, new version of image with latest changes, whatever the changes you have latest recently. So all we have to do is we have to write a Docker file. You have to write a Docker file with your instructions, what you wanted to do, what you wanted to have in this image. Let's see some sample Docker files. So there will be huge Docker files. There will be very very small ones. But see, like let's say this one, very small, right? This file, like 4 lines. Maybe let's take this one, maybe 10, 11 lines. Maybe let's take. I'm just showing you the structure. The size actually depends on your requirement, what you want to have within the image. Not, don't get confused, don't get scared about, how this is too huge. No, it's not too huge actually. We have some instructions which we need to follow in Dockerfile, and that's it. It will just you can simply use those instructions and write the Dockerfile based on your requirement. So I'll explain all these instructions. Don't worry. So first, let's create a Dockerfile. How to create Dockerfile? Simple. Just create a file, text file, sample file called Dockerfile. So just create a file, Dockerfile, capital D. Remember that. This is the default file name, Dockerfile. If you change the name by default, let's say cap small d, Docker won't identify it. So, but default is capital D. See Dockerfile, there is no space. Just create an empty file. There is no extension. There is nothing here. Just empty file we created. Now here we'll add, a few instructions. Let's see what are those instructions are. For now, just let's simply save this file. There's nothing inside, but yeah. So the first, let's open Notepad. So the first instruction inside, sorry, yeah, the first instruction inside the Docker file will be from, capital from. Remember, I wrote as capital from. So what is this from means? It's something we will be defining the base image. Let's take example. See, we downloaded the image, correct? Something, let's say Tomcat, and we ran the container, obviously out of this, correct? So now, what is the base of the container? Obviously, this image. And here we committed a container, correct? You got your own image now. This one, Tomcat one, blah blah something. You committed a container, and you got your own image. But what is the base of your own image? Obviously, this image, right? Out of this only container is created. Out of this only container is created. Out of the container, you just created your own image. But internally, this is the base image. So base image, base image. Base image is something like on top of the image, you're configuring your requirements, right? Correct. That's what we are trying to do now. We download the Tomcat image or we download Ubuntu image. On top of Ubuntu image, we create our own thing. So that's what we're doing, right? That's what usually we do. So what is the base image in our case? The base image changes. The base image changes depends on the requirement. So the base image changes based on the requirement. So let's say I'm deploying a Python application. What happens? You'll be using the Python based image. If I use Java, I'll use the Java based image. Depends on the requirement what you want to use. For now, Tomcat, right? Let's use Tomcat. People will be use Ubuntu also, CentOS also. I told you it depends on the use case. There will be lots of use cases, not just one use case particularly. Lots of things depends on the use cases. We'll be using it. So now my requirement is for now in our case, I'm just deploying an application into Tomcat. So I'll be using Tomcat image. Tomcat, what is the tag? 9.0-J or 11. This is the base image I wanted to use. So on top of this base image, everything will be present. everything will be present, correct? Now, what is that you want in this? Uh, what is that you want to achieve in this by writing this Docker file? To build your own image with your own configuration or application and everything, right? Let's see few other instructions and how to use them. Let's say there is something called maintainer, which is not required, but yeah, keep it just like author. Who is the author of this Docker file? Simply write anything, but it's not really you know matter whether it's present or not, just for identification. That's it. So you can write like this. Now there is something called run. Oh, sorry, let's something called copy. Copy, like you want to copy something to your image, some files and directories from your local. You can use the copy. Why I want to copy? So you remember we created a container and we copied the sample var file, right? The same thing we can copy. The same thing here. We'll be using this copy. Here is the sample var file. Do remember one thing I wanted to say. If you copy where your source, I mean that is this is the source, destination, user, local, Tomcat. I think this is the one that's correct. I think this, yeah. So let's say you can copy only the files which are present in the correct directory, same as Dockerfile. Let's say my folder is there, let's say lib as an example, which is outside of the Dockerfile, outside of the Dockerfile. By default, you can't do that. There is a trick for that, but by default, you can't do that. So the content, whatever the data you want to copy in, while building an image, the content, the data should be present in the same directory as Dockerfile. That's now I want to copy some more thing, maybe some more files. Simply use copy something. Let's say Tomcat user dot xml file. I want to copy to slash user slash local slash tomcat slash conf. I think this is the path. Yeah, so like this. You want to copy one more thing? You can copy simply. Write a copy again. Write this source and destination. You can write like this. Now there is one more thing called add. Add, what happens is add also can copy the file. Similar way here, what copy it. Add also can copy the files and directories. But add have few more advantages. Add can download the files also from URL. As an example, I want to download maybe not this. Let's try this one. Yeah, I want to download this sample web app. Copy link address, paste. Sorry. Yeah. Here you want to download destination slash user slash local tomcat slash web apps. I'm just giving this folder. You can give anything based on your requirement or where you want to download. So add and copy. Usually they'll ask a question. What's the difference between add and copy? Copy just copy the data. That's it. Add can also copy the data, but add have other advantages. Like add can download the file like this from URL, just like wget. If you give wget URL, it download the file right from internet. Similar way, add can also do that. So you have to give the URL and the destination path where you want to download it. So like that. And add have also another thing called unarchiving feature. It means if you give a zip file or tar file, it will unarchive them, untar them, unzip them. Unarchive usually we call it a common term. So it will do that also. So it's a common question usually people ask. Now let's say what is our other thing? Add copy. There is something called run. This run is to execute any commands. See, once we write this Docker file, we execute this Docker file, and it will start executing it. So what happens now here is, these are all not commands, right? I'm just copying it by using some instruction by Dockerfile. But if you want to execute any commands, let's say within this image, let's say you're using a Tomcat image, you want to, it may be Linux inside it. So you want to execute any, command, let's say touch test file, something, any command while building an image, you can use the run. Any command you want to use. Run. I want to do one more mkdir test directory. You can write this, or you can write like this, like this. If you want to execute any commands, you can use run. So, but this is not the correct way to use, because run, these are commands, right? Commands can run together. I mean, of course, we can't copy like this. Commands can run together like this in Linux, if you know this, right? Commands can run like this, because now one run we are using one command, one instruction we are using, and we are executing three commands, which will be useful, right? The file size will, I mean, the lines will be less. The advantage by using like this is the Docker image size also will be less. The whole point of Docker is to have the less size, applications. So when you use, let's say, run like this multiple, let's go, sorry, run like this, the more instructions you use, these are the instructions from Dockerfile. The more instructions you use, the huge the size will be. The less you use, the less the size will be, obviously. So I can run like these multiple run statements, but I don't want to run, because I can able to do the task in the same single statement itself, single instruction itself. Why to run separately if I can do the same in a single shot? That's why I'm doing like this. So these commands will execute while building the image. Now there is one more thing called work directory. It's like a CD. It's like a CD. Now if you want to go inside a folder inside this image, you can go. Let's say I want to go to slash opt as an example. Now what happens is, it will go to opt directory. That's it. That's what it does. Now there is something called user. Sorry, we have to give an user here. Let's say test. So the instructions that, will be whatever the commands we write will run as this user. But we make sure that the user is present within this image before using that. Let's say in the Tomcat user, I'm pretty sure test user won't exist. It will throw error. Say, hey, test user does not exist. So make sure the user exists before using it. If you don't know what is the username, you can ignore it. Once you first time you build the image, you'll know, okay, what's the user inside it. So based on that you can use it. Or you can create your own user. How to create? User add commands are there. Run statement, add another run statement to, or just simply do this user add, what is the user test something, what is the command, the Linux command. Once that is done, you can use user here like this. But now I don't want it, so it's fine. Sorry. That's about user. Now there is one more called expose. This is the container port which you will be using. See, as of now we are using default ports, right? Tomcat container port 8080, Jenkins or 8080, Meson or 9000 something. While writing a Docker file, you can have your own port number. Make sure the application is running the port number. Let's say in my configuration, I modified Tomcat to run on 9090 port. So you have to use here expose as 9090. It means the container will expose this port to access. So, and then we have to map the host port to container port. Got it? Let's say now Your application is running in 8080 as an example, but I gave expose as 9090. It won't work. Your application is running 8080. You have to expose the correct port, or multiple ports you can do like this. But if you give the wrong port, if you expose the wrong port, you cannot access the application. So make sure you expose the right port. By default, container port is, Tomcat port is 8080. I didn't change it. So I just simply give 8080. Or if it is a default port, you don't need to give at all. Why to give the default port? Correct? If it is the default value is the one which you gave here, why to write a new line again? No need to write. You simply comment it. So apart from these, there is one more, few more things. So it's already late, but yeah, for today, let's try these commands. That's it. Let's copy these commands. Let's go to our server. Let's we have the Docker file, I guess. Yes, we have the Docker file. Open it, paste it. See, it's commented. Yeah, you can. It's commented. You can see. Now save it. Let's try to execute this. How to execute this? The command is docker build. Docker build is the command to execute this. Docker build, and we have to pass few arguments. Hyphen t. T means tag. What is the image name? We are building the image name from beginning, from scratch. You have to give a name. What is the name? Tomcat version 1, let's say example. If you don't give the tag, it will take the latest, but you have to give mandatory. And last, you have to give the Dockerfile path. Here is the Dockerfile here in the same directory. So just do dot. Let's say Dockerfile is in different folder. Just simply give slash opt. Let's say the Dockerfile is in opt. Just give slash opt. No need to give the file name. It will just automatically read the file. If the name is Dockerfile with capital D. If the name is different, you have to give the name also. You have to pass like this hyphen F. Sorry, first let's try that. Don't confuse. So now my file name is Dockerfile, which is present in the same path. So I just simply give dot. Enter. Obviously, it failed if you observe here. Tomcat users.xml, I told Dockerfile to copy. It's failed. See, the file does not exist, obviously. Let me just create a sample file. Tomcat users.xml. I created some. Sorry. Now let's run image. Sorry, the build command. It's built. But observe clearly, it will do one by one. This is the first line, correct? Second line, see maintainer, third copy, fourth copy videos, fifth add. It downloaded too. See, it downloaded. You can see here. And the sixth command run. It executed these commands. 7 work rate. It went into OPT directory. I think that is the last. Remaining we commented. You see, it's showing something like steps 1 by 7, 2 by 7, 3 by 7 like this. These are all called layers. So in Docker image, there will be something called layer. So how the Docker image looks like is there will be a base image, right? Tomcat, whatever we use. On top of it, all these whatever we have written instructions will be applied, like onion ring, let's say, onion layer. So the core layer is Tomcat image we have, and on top of it, each and every layer is present, not lines, the instruction. Let's say here 2 lines are there for add, but no, it's considered as one layer because the instruction is one. So if no matter how many instructions we use, that many layers will be present on top of the base image. So 2, 3, 4, 5, 6, 7 layers if you remember, including the from base image, it's 7 layers. That's why the 7. Sorry, that's why the 7 layers. So usually everyone try to use less layers as much as possible because the layers, the more the layers, the more the size, obviously. So you have to reduce the size. Usually we'll keep the size minimal So use less layers as much as possible. That's why I told the run example here. Got it? So even if you pull some image, it will download like that, layer by layer only. I think it's, yeah, see here, we are pulling Tomcat, right? See why these many things it is showing. These are all layers. This Tomcat, whatever the JR11 image, built by some guy who we don't know. He published it into Docker Hub, which is available to download for anyone. When we download it, it will come by layer only. See like this. If you observe here, no two things are same. It's IDs. So these are all layers actually. That guy also, I mean, whoever wrote this, he also have written some Docker file something like this by using these instructions layer by layer. It will download, it will build layer by layer obviously for us. You have seen, you have seen the build here. It will build by layer, and while downloading, it will download also layer by layer. These are called layers. So layers has to be very less only because as I told you, the less layer, the less size. The more layers, the more size. So keep the layers less as much as possible. And by the way, Docker file is not finished. We are yet to. We have few more, instructions by Docker similar to like this. But don't worry, we'll cover that tomorrow. No need to rush. Got it? Until now, any doubts so far? Is it confusing? Any questions?
So after we create this
Yeah,
Docker file, we build an image, right? So we can
that
also
we'll
commit this
discuss maybe
message
tomorrow
into
or day after tomorrow.
the
We can do
Docker
it,
hub,
yes.
just like
But we'll discuss
GitHub.
that. I haven't started that yet. Okay?
Okay,
But so-
okay. Can
yeah,
we run this
sorry, I
image
forgot.
now? We
We
built it,
cannot run
right? We
obviously.
run and
It won't work
check the.
because I told you right few more instructions. But let's try. Where is our image? See Tomcat image. This is our image. We see. Run a container. I think it should work. Docker run -d -p 808280. What is the port number I gave? I think it's the default one. Yeah, 8080. Name test Tomcat colon v1. Oh, 80 it's already in use. Sorry, my bad. 8083 maybe I think it's might be free. Yeah. Is it running? Yes, it's running. Let's go inside it. See, Java is there by default because Tomcat. What is the Docker file we wrote? We copied. Let's go to user local Tomcat. What is there? See, sample web app we downloaded with add sample.wire file we copied with copy. So we got both right. This of course Tomcat user also will be present. Touch test file. These are all things. Let's see these slash test something like that. There is a test folder. Yes, test two. This is what we have written. See, we have written this. These are the things we have written. So whatever you gave here, it will be get executed once you execute the image. I mean the file. It means building the image. Still, there are few more instructions which are major things. So without, you may ask, we haven't finished the Docker file. Still, you told there are few instructions, but how it works, that we'll discuss tomorrow. How it works and why the Tomcat is working. It should not work right if you don't finish fully. But that's what. Let's see that tomorrow. All right. So until then, do practice. I'll share this. I mean, it's not really a big thing. You can practice. Keep this as a reference. That's it. So you can write a better one, obviously. So it's just for practice. So yeah, any doubts so far? Anything? Any questions? Anything? Yes. Okay. I shared the document already with
No, bro.
Dockerfile also present. Please practice. Yeah, and we'll continue the remaining Dockerfile everything tomorrow. Okay. Bye. Bye all. Bye. Sorry, I forgot. Sorry.
Okay.
Tomorrow same time.
So
We
tomorrow it's
cannot make it
morning, right?
morning.
The class.
So we have to adjust for maybe tomorrow Thursday. I think yeah. Thursday just yeah. Tomorrow is just the last 8 p.m. class. Don't worry. I have morning tomorrow meeting. So yeah, 8 p.m. same time tomorrow.
Okay.
Or wait. Let me just see. Let me just see the calendar. Maybe tomorrow. I'm still confused. That's okay. I'll mention in the group. That's okay. Yeah. All right then. Yeah. Bye. Bye. All.
Okay.